Guys, welcome back to SciMath, and today we're going to be talking about the topic of determinants and how to find determinants for different types of matrices. So let's get started. Firstly, I want to start off by going through the list of topics that will be discussed in this video. So here's the list of topics that we will be going over. The first is how to find the determinant of a 2x2 matrix. The second is how to find the determinant of a 3x3 matrix using the graphical method. The third is going over a lower triangular and an upper triangular matrix example and how to find the determinant of those. I will also be going over what a lower and upper triangular matrix mean. The fourth is finding the determinant of a diagonal matrix. Fifth is understanding that the determinant of A transpose is equal to the determinant of A. And then lastly, understanding that the determinant of A inverse can be found by doing 1 over determinant of A. So let's go to our first example. So here's our first example of a 2x2 matrix. And here we can see that this is a 2x2 matrix because we have 2 rows and 2 columns here. So the formula to find the determinant of a 2x2 matrix is this. The determinant of matrix A, and the determinant can also be denoted by these absolute value bars, is going to be AD minus BC. So now that we know the formula of how to find the determinant of a 2x2 matrix, all we need to do is recognize what each element is signifying which letter. So in a 2x2 matrix, as you can see here, when we arrange a 2x2 matrix, the first element is A, the second is B, the third is C, and the fourth one is D. So similarly now, let's assign A, B, C, D values to our given matrix in the example. So our A in this case would be 3, our B would be 5, C would be 2, and D would be 4. So now it's just a matter of plugging it into the formula. So when we plug this into the formula, we get 3 times 4 minus 5 times 2, which is equal to 12 minus 10, and therefore the determinant of our matrix is 2. Let's move on to the next example. So our next example is that of a 3x3 matrix. As you can see here in this example, we're given matrix B, which is 3x3, because we can see that we have 3 rows and 3 columns. So the way that we're going to find the determinant of this is called the graphical method. Now there's 2 ways you could find the determinant of a 3x3 matrix. One is using cofactor expansion or the graphical method. And in this video, I'm going to go over the graphical method because it's easier to do and saves time on an exam. But if you want to learn more about cofactor expansion, you're welcome to learn more about it. But in this video, I'm going to be talking specifically about graphical method. So let's see how it works. So the first step in the graphical method is writing out your matrix that you're given. And as you can see here, this is not the matrix, like the full matrix, but what you basically do is you write the original matrix that you're given, the 3x3, and then you duplicate the first 2 columns of it right next to it. So as you can see here, I've duplicated the first and the second column, which is 1, 0, 1 and 2, 4, 0. So that's the first step that you would do in the graphical method. Then what you would do is you would multiply the diagonal entries. So basically what you would do is you would start from the left-hand side of the matrix, and with that first element here at the top, which is 1 in our case, you would go from there and you would multiply these elements diagonally till you get to the third element. So let me show you what I mean by that. So this is the way you would multiply the elements. The lines I've drawn there are to indicate which direction you're supposed to multiply the elements in. So in our case, this would be 1 times 4 times 6, and you would add all of these multiplications. So in this case, like 1 times 4 times 6 is 24, then we would add 24 to the next diagonal multiplication, which would be 2 times 5 times 1, which is 10. So we would do 24 plus 10. And that third row is 3 times 0 times 0, which is just gives us 0. So we would do 24 plus 10, which gives us 34. The next step in the process is after you get to the third element of the matrix, you take that third element, in this case, which is 3, the one in the middle, and you multiply the other side diagonal entries by that element. So in this case, it would be 3 times 4 times 1, which is 12, and then you keep doing that with the other 2 as well in this direction instead. So we would do 1 times 5 times 0, which gives us 0, and then 6, or 2 times 0 times 6, which gives us 0. So we just end up with 12. So as you can see here, I've written down the sums of all the multiplications. So the one at the bottom, the 34, is the sum and multiplication for all the diagonals that we did first, and then the one at the top is the one that we went the other direction in for 12. So once you add all the elements, when you multiply them, what you basically do in the last step is you subtract the number at the bottom here that you get, which is this direction diagonal. That sum you subtract by the one at the top. So in this case, we would do 34 minus 12, and you would get your determinant of the 3 by 3 matrix. So let's do that. So as you can see, I just subtracted 34 minus 12, and we get that the determinant of matrix B is 22. Let's move on to the next example. So our next example is that of a lower triangular matrix. And basically, a lower triangular matrix is just whenever the top three entries here that sort of make this triangle shape, as you can see, are zeros. And so a lower triangular matrix is when all these top three zero entries, or all these top three element entries are zero. And vice versa, for an upper triangular matrix, these three entries would be zeros, and that's what would make it an upper triangular matrix. Now, the easy way to remember is, as you can see, even though this matrix is called the lower triangular matrix, all the zeros are at the top, and then in an upper triangular matrix, it's the opposite. All the zeros are at the bottom. So that's an easy way to remember what a lower and upper triangular matrix look like. So now, the way to find the determinant of a lower triangular matrix is basically just taking the product of all the diagonal entries in the matrix. So let's do that. So like I said, the way to find the determinant of a lower triangular matrix is just doing the product of the diagonal entries in the matrix. So in this case, it would be 3 times 5 times 2, which gives us 30. So the determinant of the lower triangular matrix is 30. Let's move on to the next example of an upper triangular matrix. So our next example is that of a matrix which is an upper triangular matrix. And as you can see here, as I mentioned before, an upper triangular matrix would just mean that these three zeros here that make a triangle sort of shape would be zeros. The entries in here would be zero, which tells us that it's an upper triangular matrix. And basically, for both of these triangular matrices, whether it be a lower triangular matrix or upper triangular matrix, the way to find its determinant is the same. We still take the product of the diagonal entries on the matrix. So in this case, it would be 7 times 4 times 6. So let's do that and see what we get. So when we follow the formula, we get 7 times 4 times 6, which gives us that the determinant of matrix D in this case is 168. Let's move on to the next example. So our next example is that of a diagonal matrix. Here, we know this is a diagonal matrix because of the fact that except the diagonal entries, all the other entries in the matrix are zero. So basically, you were looking at a diagonal matrix whenever the entries on the main diagonal are non-zero values and everything else around it are zeros. So the way to find the determinant of a diagonal matrix is actually the same as finding that of a lower or upper triangular matrix. You just take the product of the diagonal entries in the matrix. So let's do that. So when we plug it into the formula that we know, or the way to do it, we get 2 times negative 3 times 4, which tells us that the determinant of matrix B in this case is negative 24. And it's okay to have a determinant that is a negative value. It is common. It's not like you have to get a positive value for a determinant. So in this case, our determinant is negative 24. Let's move on to the next example. So our next example, as I had mentioned in the list of topics that we were going to discuss in the video, was showing how the determinant of A transpose is equal to the determinant of A. So in this case here, we are given a 3 by 3 matrix, which is matrix A. So now I want to talk about what the transpose of a matrix means. The transpose of a matrix basically means when you take either your columns or your rows and you shift them. You either turn your columns into rows or you turn your rows into columns. Either way, it's the same thing, because in an n by n matrix, meaning when it's a square matrix, which has the same number of rows or columns, no matter what you do with the transpose, either way is going to be the same. So if we take these columns, for example, in this case, and turn them into rows, let's see what A transpose would look like. So as you can see here, I've written out A transpose now, and you could just think of it like, imagine taking these columns and just turning it into rows one by one. So the first column would be the first row, the second column would be the second row, and the third column would be the third row. So this is what we mean when we were taking a transpose. Similarly, you could have taken the first row, turned it into the first column, taken the second row, turned it into the second column, taken the third row, and put it into the third column. Either way, you would get the same answer. So here we have A transpose now. Now we're going to find the determinant of each of these and prove that it will be the same. So let's do that. So here, as you can see, I found first the determinant of matrix A by doing the graphical method again. So you have a good chance here of applying the graphical method skills that you learned to find the determinant of a 3 by 3 matrix quickly. And so when I did all those steps out, I get that 39 plus 15, which tells us that the determinant of matrix A is 54. Now let's take the determinant of A transpose to see if it's the same. So now I went ahead and found the determinant of A transpose, and as you can see here, when we did it by the graphical method, we still ended up getting 39 for the bottom multiplication and negative 15 for the top. That itself should tell you that the determinant is going to be the same, and as you can see, both determinant of A and determinant of A transpose is 54, so we've proven that this is true. Let's move on to the next example. So in this next example, we want to prove that the determinant of A inverse is equal to 1 over determinant of A. So in this example here, we're given matrix H, and it's a 2 by 2 matrix, as we can see, because we have 2 rows and 2 columns. So let's prove that the determinant of H inverse is equal to 1 over determinant of H. So first step would be to find determinant of H. Let's do that. So as you can see here, I found out determinant of matrix H, where we did our 2 by 2 matrix way, and so we got that the determinant of H is equal to 1. And so now to find the determinant of H inverse, all we need to do is do 1 over determinant of H. So here we have 1 over 1, which tells us that the determinant of H inverse will also be 1. Now here in this example, this was a very simple way to do it, because first of all, it was a 2 by 2 matrix, and also the determinant came out to be 1, so there weren't any other numbers, but this is the way to find the determinant of an inverse of a matrix. So I hope you enjoyed this video and learned something new, and don't forget to like, share, and subscribe.